Problem 90. This is an involved problem. The solvent dichloromethane, CH2Cl2, it gives you the molar mass, can be prepared by reaction of methane and chlorine. And it gives you the molar masses of methane and chlorine. And this is according to the balanced equation right here. Now we're asked 5 different questions, and you can kind of go in order. So I've calculated, or I have copied the chemical equation over here, and I've also put down the molar masses that were given to us in the problem right there below the chemicals. The first one says if 5 grams of methane, that's CH4, and 15 grams of Cl2 are used, how many moles of each reactant are used? Now, there is multiple ways to answer this question. What I'm going to do is to first determine the limiting reactant using the method that I outlined in the lectures and also in the previous couple problems. And then once we know the limiting reactant and the amount of product that's formed, we're going to be able to come back and answer A as well. So we're going to do B and C first, and then we'll come back and answer A. So let's first find the limiting reactant. If you have 5 grams of methane reacting with 15 grams of chlorine, the way you can determine the limiting reactant is just to figure out how many moles of the product that each one would form if they both fully reacted. And so we take methane first. So 5 grams of methane, convert that to moles using the molar mass, and then go from moles of methane to moles of product. This is a 1-to-1 ratio. You can see the units canceling out. And so 5 over 16.04, let's punch that in. 5 over 16.04, and I get 0.31172. So 0.31172. This would be a 3 sig fig number because of the 3 sig figs here. And then similar calculation for chlorine. 15 grams of chlorine, convert grams to moles using the molar mass. And then go from moles of chlorine to moles of product. Oh, I see a typo here. This is a 2-to-1 ratio. I got to change that to a 2. So let me do that. Glad I didn't do the calculation yet. So you can see that the unit's working out. We're going to get moles of product again. Let's punch in the calculation. So 15 over 70.9D, and then divided by 2, and that'll give us 0.10578. 0.10578. So this will be a 3 sig fig answer again. But you see, comparing these two, it's the chlorine which is going to give us the lesser amount of product. So we can say that over here that the chlorine is the limiting reactant, and this is going to be how many moles of product are formed. That's the theoretical yield of product that's formed. Okay, so what we've done is we've answered B and C. B, the limiting reactant, is going to be the chlorine. And then the moles of product is going to be 0.106 if we round it, 0.106 moles of product, CH2Cl2. Now what we're going to do after this is go back and figure out what A is. So if 5 grams of methane and 15 grams of chlorine are used, how many moles of each reactant are used? The way we're going to do this is we're going to take the moles of product that we know are formed, 0.10578. We're going to use the unrounded value, but just remembering this is a 3 sig fig number. So this many moles of product CH2Cl2, and then we're going to work backwards to figure out how many moles of reactant it came from. Okay, so let's turn product into methane first. This is a 1-to-1 ratio. And then we'll do product to chlorine, the 1-to-2 ratio. So going product to methane, if we form this many moles of product, it's a 1-to-1 ratio with methane. So 1 mole of product CH2Cl2 from 1 mole of methane. And so that's 0.10578 moles of methane that must have reacted. And then doing a similar calculation for the chlorine, let's just copy this and paste it right there. And we're going to change this, get rid of some of this stuff. This will be the chlorine up here, and that'll be a different answer. So let's moles of chlorine. And remember, for chlorine, it's a 1-to-2 ratio. Now we get these from the coefficients in the chemical equation. Okay, so you can see the units canceling like they did up there, and we'll be left with moles of chlorine. I've got to change this to chlorine over here. So chlorine, there we go. And this will be 0.10578 times 2. So 0.21156. 0.21156. Now this is a 3 sig fig number, so it's going to round to 0.212 moles of chlorine. And then up here when we did methane, that'll round to 0.106 moles of methane. So that answers A, B, C so far. So A, B, C. How about D? So D comes next. And what do we got here for D? How many grams of product are formed? Well, we can turn moles of product into grams of product. So we already figured out how many moles of product are formed. So let's take this down and copy it there. So that's going to be, using the unrounded value, of course, 0.10578 moles of product, CH4Cl2, 3 sig fig number. And then using the molar mass in the problem, that's 84.93 grams per mole. We can convert it to grams. Whoops. So 84.93 grams for every 1 mole. And so that's going to cancel the mole units. We'll be left with grams. Doing the calculation. 0.10578 times 84.93. And that gets us 8.9838. 8.9838 grams of the product, CH2Cl2. This will be a 3 sig fig result. So 8.93 grams of CH2Cl2. So that's the answer for D. And then finally, one more. E. Okay, if 5.6 grams of product are formed, what is the percent yield of this reaction? So remember, a percent yield is going to be actual over theoretical times 100%. So we can plug in these numbers. It's going to be equal to the actual yield. It says, suppose that's what you form. That's the actual yield. 5.6 grams. Okay, times 100 divided by theoretical yield. Since this is only 2 sig figs, we could use the the rounded one, but we can use the unrounded one as well. Oh wait, the grams of product are over here. Okay, so that's how many grams of product. We could use the unrounded one, but this is a 3 sig fig rounded one, so that's good enough. So we'll copy that one. And 8.93 grams. So we're going to have 5.6 over 8.93 times 100. I get 62.70%. 62.70%. This is only a 2 sig fig percent yield because of the 2 sig figs here. So this is going to round to 63%. And there you go. That's E. Kind of involved problem there.